insert this further. Okay, so so what we've seen here is that any logic allows us to insert these little snippets of Java code that says what value should be held, like for dx or dy or the number of replications, and it takes care of the how for most of this stuff. It takes care of automatically kind of doing things behind the scenes to make that actually happen. I think I'm going to skip this out, but I think what I'm going to do here, what I'm going to do right now is go and we'll add a little bit of agent connections here to spread infection, okay? So we're going to have these agents spread infection to one another. So again, this is a rehearsal of things we saw this morning, okay? So we're going to have agents go through, say, 3 states: susceptible, infected, and recovered. And we're going to have them interact with each other through the network rather than through in space this morning. Okay, so folks, riddle me this. How would I have agents go through a natural history of infection described by a state chart? Where do I put that in my model? Sorry? Okay, in person, because it's a characteristic of a person. It's part of their personhood, their personness. It's part of being a person that you'll have states of infection. Good. Okay, so I've double-clicked on person. What do I do now? Who else needs help? Who else would like help? TAs are poised. That's a great idea. Yeah. No, that's a great idea. Okay, folks. So tell me how to go add a state chart. Where do I go? Sorry. Palette state chart. So I opened up person, and then I go to the state chart here, which is down here, and tell me how to draw a state chart with SI and R in it. Okay, so what do I drag first? State chart entry point. Excellent. I'll just leave its name by default since I'm not going to have multiple state charts. I could have called it infection state chart. Well, probably for best practice. No, I'll leave it as state chart so people don't have to worry. Okay, and what do I have to do for the states? Drag state over here. I'm hearing good things here. Okay, so I'm going to create a state called susceptible. I'm going to create a state called infectious, and I will create a state called recovered. Recovered, okay. And how do I? Okay, so now suppose I want these agents to kind of go between these states. What sort of thing do I use to describe that? Transition. Okay, where do I get a transition from? Okay. Can I use a line for the transition? No. You have to be very careful about this, folks. There's several things over here in the palette that look temptingly like transitions, but are there to fool. Can I use this link as a transition? No. I need to use the one in state chart. Okay, so folks, what do I do? Suppose I want to put one between susceptible and infected. What do I do? Drag it over. Okay, oh, it fits nicely. Okay, how about one between infectious and recovered? Well, similar, okay? Okay, now, maybe for some of you, you dragged it and it didn't quite connect. Be sure that you drag it so that it's connected, okay? Okay, that's great. Okay, how about susceptible and infectious? Well, let's suppose infectious and recovered. Let's suppose we want them to have a chance of 10% per day for covering. Kind of a nasty case, really nasty case of the flip. 10% chance per day of recovery. How would I describe that? Notice how I phrase that. 10% chance per day. That is a probability density. It's a hazard. So what do I use? I use a rate. I use a rate associated with that transition. Okay? Okay, and the rate is going to be what? 1 divided by 10. So, or actually, okay, folks, you got to watch out for this. I got to warn you. People get bitten by this. Professional developers who are working at 2 a.m. on the next version of next version of software projects, they'll get bitten by this. Do not put this in. What's the matter with that? Can anyone say?
Integer division?
It's integer division. What will the value be?
0.
It'll be 0. So if you wanted to do something like that, you could do this, in which case it'll be double division. I'm sorry to drag you into the horrible vagaries, but this will actually give you what you want, which is 0.1, okay? 1 divided by 10, it'll treat those as if it's trying to divide integers, and it will return a value of 0, which logically makes sense, but is the cause of many unfortunate bugs over the years. So this is going to be recovery. It's a rate of 0.1. In other words, we spend an average of 10 days infectious, okay? We have a 10% chance per day of recovering. Okay, now, ladies and gentlemen, the crux of this is where the chickens come home to roost. This is where the fox will show its tail. Is this issue of susceptible to infection, to infected. If we want infection to spread in this model, how are we going to set this up to spread? I actually mentioned it one time that there's an appropriate type of transition, but you can tell me what it would be. Ladies and gentlemen, of all these transitions, which type would be appropriate if we want to capture spread of infection? What's the sort of easy one for us to use? Is it a timeout? What is a timeout? Okay. Well, okay, a message transition is it. A timeout is for a fixed amount of time. We can specify that with a variable, so different, and an exact amount of time for each time. It can be a rate, which is a chance per unit of time. It can be a condition under these situations. We undertake this agent arrival at a location when they're moving, but none of those are really appropriate. It's really message. Okay, so we want to set that, ladies and gentlemen, to message. A message transition, okay? So when this agent receives a message, they get a transition. Now, if we run this model now, what will happen? Why? Why will nothing happen? What's that?
Where is the message?
Sorry?
There is no message.
Okay, there's no message being sent. So where's this message going to come from? Okay, so if we want people to go from susceptible to infectious on receipt of a message, you can see we select it to be message. We say it could be any type of message. Okay, who's going to send this message? Who is it that it infects people? Other people. Other people who are recovered? Other people who are susceptible? Infective other people, infectious other people. I could have called them infective. Okay, so we need those infectious people to be contacting other people, say with a rate of, say, 2 per day. Let's suppose, make it a high rate, say 10 per day. They're contacting other people. And how do they contact them? Say 10, I'm sorry, say 2 per day. I 10, just doing the math in my head, 10 is a bit much. How do they contact them? Sorry? Well, okay. Yes, this could represent needle sharing. It's true. But in this thing, okay, so these people who are ill, how are they going to affect other people? They do what to them? They contact them, and how is that reified in the model? How is that realized in the model? How is it represented in the model? How is it characterized in the model? Okay, but how does the other agent know it's being contacted? There's a link to it.
We did the first method already.
We send a message. Thank you. We have to send a message. Remember what got us into this kick was that these people here, when they're going from susceptible to infectious, they need to go when they receive a message. So for them to receive the message, someone has to send it. Right? Okay. So these guys need to send a message. So they're going to send a message. And the truth is, since we don't really pay attention to the payload of the message, it could be anything. But I'll just say, infected in exclamation points. And then I'll put in random. Now, this is where I start to get to. We went back to one of the questions earlier. How do we? To whom can we send a message? Well, here we're sending this message to a random person connected with us. Okay. There's AnyLogic provides a set of sort of built-in things like a random neighbor in space, a random connected person, or any random person in the entire population. Now, we could always put a particular person in here. Like if we had a reference to Joe, we could send it to Joe. But we're going to do to random, and you'll notice it's random underbar connected. Okay? Random underbar connected. Here. Yes? Thank you. Who needs help? Sorry, just.
Why do we have the transition from like the one
Because they stay in the state. They don't leave the state. It's something they do while in the state. It's an action they undertake while remaining in that state. So it's just they're undertake it while remaining in the state, and therefore it's from the state to itself. They're not even leaving the state during that. Does that make sense? Okay. Okay, so folks, who needs help with this though? Okay. Okay, so folks, we're just about there. We're just about there. But okay, that the infection will spread to the population. Okay? But if we run this model, let's go run the model. Well, okay, so let's go between people in the model. Everyone's susceptible. Why is that? Because what? Okay. So, for example, we have it all spread, we have the mechanism for spread, but nobody is starting infected. No one's starting infected. That's right. No one's starting infected. So there's two ways we could deal with this. One we dealt with earlier. Remember that branch in the state chart? We could start people, summon people infectious, right? So maybe we want to start, that would be one way to do it. The other way would be to send an initial message. Another way would be to do it by clicking on a person. We can make a person infected, and then from then on it will spread. How many people would like to do it the branch way we saw earlier? Rehearse that. Okay, one person. How many people would like to do it by just sending a random person a message at the start of the model? How many people would like to see that? Okay, 3. How many people would like to see it? So when I click on an agent, that agent gets connected. Okay. 4, 5. Okay. Okay. I don't know if the TAs count, but I think so. Sorry. Okay, well, they still, okay, they still carry the day then. Okay, so ladies and gentlemen, we're gonna go send an agent that we click on a message. But before we do that, we probably want some visual way of showing that this person is infected, okay? And there's a couple ways we can do that. We could have them turn red if they're in the infectious state. That would be one idea. Or we could have them change color for each state. Which would people like to see? Do you want us to change different colors for each state? Okay, color? Okay. Okay. So we're going to take another couple minutes then to do that. So, ladies and gentlemen, there's several ways to do this. And I'm going to show you what I consider the least painful way. But it still ain't that pretty, but it's okay. Okay, so ladies and gentlemen, I'd like you to add a variable to the model. Where do we add a variable from? The General tab of the palette. And I'd like this variable to be called color. Now, in apologies to my Canadian colleagues, it's unfortunately dictated by the spelling conventions of the American Imperium. So there's no U in the color. So I'm comfortable with it, but I apologize for that. This variable is going to be a quantity that stores colors. So we have to associate with a type. It's not an integer, it's not a double, it's not a string, it's not a Boolean. It's an other thing, and specifically what it is, it's a color with a capital C. This capital is because that's the name for a colorness, or the class called color. This is just a particular specific color in lowercase, the name of the variable. It's a reference to a particular member of this class with a capital C. So I apologize for that. So we just added a variable. Who needs help here? Help of a TA. TA help? Saw it? TA help? No? Okay. So drag in a variable. It's called color with a lowercase c, and its type is other with a capital C. I have to apologize to all my non-computer science colleagues because we are living here with the dictates of the Java Imperium, and we have to give it a type and be very explicit about it. And by these types begin with capitals. And there's a class called color that defines colorness. Okay, and that's why we give it this capital COLOR. Okay, so if you folks could stomach that, it's all downhill from here. In other words, it's getting better. Okay, so in the susceptible class, we're going to make people green. How do we do that? Well, okay, sorry. Let's put the link in. So suppose I want to make the oval be the color associated with this color. How would I do that? How if I want to change their color of the oval? How would I do that based on what we've seen? Sorry? Fill color, where is that? On the state chart? Okay, dynamic of what? Of the oval. So we go up to the oval, we go to dynamic properties, and we go to fill color, and we could say color. Whatever is in color here will be its fill color, okay? Okay, so that's great, but we still have to complete the job. We still have to make this color have the appropriate values. So suppose when people are susceptible, we want them to be green. What would I do? We would assign green to be the color, okay? Okay, so who needs help? Okay, suppose for infectious, we want their color to be red. We could assign red to be the color. Suppose recovered, we want the color to be gray. We could assign gray. It's AY because of the dictates of the British Imperium.
At least if
Yeah. So gray with a capital A rather than with an E, with a capital A rather than an E. Okay. Okay, so big picture, folks, what have we done here? We have added a variable called color. It's of type capital C color. We set up the oval such that its fill color was dictated by the color. And we set each of the states, so when you enter that state, the appropriate color is assigned. Green when they're susceptible, red when they're infectious, gray when they're recovered. Okay? And that means this color variable will be changing over time, which will automatically change the color of the person. So ladies and gentlemen, let's run this. And you should see something like this. But why are they all green? No one's infected. Okay, so we have to finish the final step. And you folks requested it, including the TAs. Well, no, there are some other hands. Okay, so now we have to make it so that when we click on an agent, we infect them. Okay? So how are we going to do that? Well, it turns out in the oval, there's something called on-click. Do you see this? So if you go to the oval, there's actually something called on-click, and that's unlike all these other properties. It's a handler. It handles, if you click on it, do this. So for this on-click event, what we want to do is we want to send a message to say that we're infected. Okay? So who are we going to send it to? Oh, sorry? To this. We're going to send it to ourselves. Because we're being clicked on, we know who we are, and therefore we send it to ourselves. Okay? Yes?
Is there a reason why you be sending up
Send is asynchronous, as I recall, and receive is synchronous. And generally I prefer send because of that. But, and I like to train people to use send by default unless they have a good reason to use receive.
That's why I asked.
Okay, so folks, let me just show that code again. What I did is for the see, the problem is with receive you can get in deadlocks, or you can get blocking states basically where it's handled, it needs to be handled immediately, and you could get in a situation where one calls one sends the receive to the other, and they eventually get locked up. You know. Okay, so folks, this was the code I put in on the on-click event for oval. Who needs help here? Who needs help? That was the final thing we're doing. Help is on its way. Okay. Who else needs help? Anyone else? Okay. So let's run this. Okay. And now let's click. Okay, folks, can you click on the agents? Do you see things that happen when you click on them? Okay, what's happening there? Folks, do you see this on your screen? Okay. Who needs help? Who wants a TA help? Okay, folks, there's huge need for TA help. So TAs arise. Okay, TAs deployed. Okay. Okay. Yeah. Okay, it's probably because it's not staying infectious long enough. So look at this transition here. Yeah. And it's timeout. It should be a rate. Yeah. And that should allow it. So R out is less than 1. So it's just timeout. Let's try. Okay. Good. Okay. Who else needs help? Help? Okay. Okay, so when you click, what happens? There you go. Yeah.
Can you show us the code again?
Sure.
For the on-click?
Yeah. Okay, so the code for the on-click was as follows. This is send infected, and it's and this could be pretty much anything, but it has to be comma this. Okay? Okay, who else needs help? I can help out someone. Does someone need help? Okay, so if people click, do they see the infection spread? Okay. Okay, so double check, double check his time to recovery. Make sure time to recovery is a rate with a rate constant of 0.1. So we'll say an average of 10 time steps. Make sure it's not a timeout with the time constant of 0.1. Okay, so more help needed? Okay. Question? Yes. Okay, so why don't you see if you can, yeah. Okay, so, okay, so when you run this right now, is it working otherwise? To this point? Just when did it stop?
Right. Yeah,
Yeah.
right. You should, yes. You could actually put in, for example, how long will it be? In fact, actually, see, that's why you put great question. What that guy was not recovered yet. I'm gonna find it. They should, yes. I mean, that's, you just read the state chart, that's what it says, right?
That's the most computer, because this other one is computer.
Well, the thing is that, for example, it does, it's fine. It's just a very long, that's what happens. But you can also code it so that when you click on something, it should be moved inside the other.
Yeah.
Which is what I created.
Well, because I wouldn't think that was okay, yeah, where does it do that? It's a, it doesn't make sense. Okay, I'm tempted to close it and so you'll lose some things. This is another weird thing. So try running on so these state charts don't appear at all. So what I would do is just see if the state chart transitions in here are occurring by then a transition fires through the trace cell and see if it's actually something that's not clear. It could be clearing visually, but it's not. And do a trace cell on one of your things, and that will help you. Okay. So, ladies and gentlemen, I think that will, do people have this running then? Did it work? Okay, good. So, is it firing? Okay, okay. Okay, so I think we'll sort of call it a day as far as the instruction on this is concerned.